In our last video, I showed you the derivation of the quadratic formula x is equal to negative b plus or minus root of b squared minus 4ac all over 2a. Now we're going to use this quadratic formula to solve for the roots of a quadratic equation. So for the first example, we have x squared is equal to negative 4x plus 21. The first thing what I need to do is to identify the values of a, b, and c. And for you to identify the a value, the b value, and the c value, make sure that the quadratic equation is in standard form first, which means that we need to equate the equation to 0. And this becomes x squared. Negative 4x becomes plus 4x if we transfer this to the right side. Plus 21 becomes minus 21. And then we have here 0. So which means the a value is the coefficient of x squared, that is 1. B, coefficient of x, which is 4. And our c is negative 21. A is 1, b is 4, c is negative 21, and now we're ready to plug them in into the quadratic formula. So solving for the values of x, we now have negative of b plus or minus root of b squared, which is 4 squared, minus 4 times our a value times our c value, negative 21. Divide by 2 times our a value, 1. Simplify the inside the square root sign, which is called the discriminant. 4 squared is 16, minus 4 times 1 times negative 21 becomes plus 84, and then we have divide by 2. So to simplify this, we now have x is equal to negative 4 plus or minus root of 100 divided by 2. And what is the square root of 100? It is 10, right? So to solve for the two values of x, we now have x is equal to negative 4 plus root 100 is 10, so we put 10 over 2, which means the other value of x will be negative 4 minus 10 root 2. Because the square root of 100 is positive 10 or negative 10. Because when you square 10, that's positive 100. When you square negative 10, that's also 100. So simplifying this, we now have negative 4 plus 10 is 6. 6 divided by 2 is 3. So that's one of the zeros of this quadratic equation. The second value of x, negative 4 minus 10 is negative 14. Divided by 2, we have negative 7. So the zeros, or the values of x that will make this equation true, are 3 and negative 7. Again, find the values of a, b, and c, plug them in to the quadratic formula, and solve for the values of x. Now let's have example number 2. In this example, 4x squared minus 20x plus 25 is equal to 0. This quadratic equation is already in standard form, so we can easily get now the values of a, b, and c. So the a value is 4. The b value is negative 20. Be careful with that sign. And c is positive 25. And then we will substitute now the values into our quadratic formula. So we have negative of negative 20. That turns now to positive 20. Plus or minus, we have negative 20 squared minus 4 times our a value times our c value, 25. And then we have 2 divided by 4. Simplifying this further, we have 20 plus or minus negative 20 squared is 400. Negative 4, I'm going to multiply first 25 times 4, that's the 100, times negative 4, that's also negative 4. and that gives us 8 in your denominator. So simplifying the discriminant, we have 20 plus or minus, the discriminant becomes the root of 0. And we know that the root of 0 is also 0. So if the discriminant is 0, that means we will only have one answer for this quadratic equation, which is 20 over 8, and in simplest form, that is 5 over 2, because this means we can simplify the fraction by dividing by 4, both numerator and denominator. So that is 5 over 2, or the same thing as 2.5, which means that the 2.5 will make the equation true. And when you graph a quadratic function, this means that the parabola will have an x-intercept of 2.50. In our example number 1, we got a discriminant of positive, so we had two values of x, or two x-intercepts. In our second example, our discriminant is 0, and we have one value of x, which means we have one x-intercept. So in our first example, we have a quadratic equation with two roots. Second example, we have one root, or one value of x. Now let's take a look at example number 3. 3x squared plus 6x plus 10 equals 0. And in our first two examples, we have a quadratic equation with two roots, and we also have a quadratic equation with one root. Now let's take a look at example number 3. 3x squared plus 6x plus 10 is equal to 0. So here our a value is 3, b is 6, and c is 10. So now we're ready to plug them in into the quadratic formula. So we have negative of b, which is negative 6, plus or minus root of 6 squared minus 4 times your a value, and then times your c value 10, all over 2 times 3. So now let's simplify it. What's the answer for the discriminant? So for the discriminant, we have 6 squared is 36, minus 10 times 3 is 30, 30 times 4 is negative 120. Divide by 6. So what do you notice with the discriminant for this example? It's a negative. So we have the square root of 36 minus 20 is negative 84. So now if you notice, the discriminant is a negative number, which means you will have imaginary answer, and there is no real solutions. Which means that when you graph a quadratic equation, the graph of a parabola with the equation 3x squared plus 6x plus 10 will not cross the x-axis, which means there is no x-intercept. So again, example 1, we have two x-intercepts, or two values of x. Example 2, we have one root. And example 3, we have no root, or no real solution. Now let's have example number 4. 2x squared plus 7x is equal to 0. So in this problem, a value is 2, b value 7, and our c value is 0. There is no constant, that means we have 0. So now we're ready to plug them in into the formula. We have negative 7 plus or minus square root of, we have 7 squared minus 4 times 2, and then times c, which is 0, divide by 2 times 2. So simplifying this, we have negative 7 plus or minus root of 7 squared is 49, and that's going to be 0, divided by 4. So we have negative 7 plus or minus root 49, which is 7, divided by 4. So here we have two values of x because the discriminant is positive. One of the values for x is negative 7 plus 7 divided by 4, which is 0 over 4, or simply 0. the second value of x is negative 7 minus 7 divided by 4, which is negative 14 over 4. In simplest form, that is negative 7 over 2, or that is negative 3.5. So which means that the graph of a parabola will have two x-intercepts. One is at 0, 0, and the other one is negative 3.5, 0. So we have two roots for this quadratic equation. For the fifth example, we have x squared plus 4x minus 3 is equal to 0. So a is 1, b is 4, and c is negative 3. Same thing, we need to plug it into the formula. We have negative 4 plus or minus b squared, so we have 4 squared, minus 4ac, so 4 times 1 times negative 3, and then we have 2 times the a value 1. Simplifying this further, we have negative 4 plus or minus 4 squared is 16. Negative 3 times 1 is negative 3. Negative 3 times negative 4 is positive 12. So we have plus 12 divided by 2. Now, this is a positive discriminant, so we're expecting two answers. Negative 4 plus or minus root 28 divided by 2. So this quadratic equation now have two roots, and one of the roots is negative 4 plus or minus. What is root 28 in simplest radical form? It's 2 root 7, because 28 is the same thing as 4 times 7. So since it's 4 times 7, we use 4 times 7 because 4 is a perfect square. So root 28 is the same thing as 2 root 7, and now we're dividing by 2. Which means the roots are negative 2 plus or minus root 7. Because to simplify it, you need to divide negative 4 divided by 2, which is negative 2, and then plus or minus 2 divided by 2, which is 1. So to get the two values of x in decimals, we will use our calculator to get the decimal equivalent of negative 2 plus root 7. And that will give us 0.65 in two decimal places, approximately. On the other hand, the second is negative 2 minus root 7, and that is negative 4, approximately negative 4.65. So these are the two values of x, or the two roots of a quadratic equation, which means that when you graph the parabola, it will also pass through the x-intercepts 0.65, 0, and negative 4.65, 0.